So let me talk you through this final review of solutions. You have space for 20 kids and 10 adults in a party. It costs $8 for an adult and $3 for a kid. You don't want to spend more than $80. So it's the sum of inequalities is basically saying this idea where you have to make multiple inequality statements from the scenario. So if you have space for 20 kids, that means you could have 20 or less. So kids would be the number of kids would have to be less than or equal to 20. If you have space for 10 adults, that means you have less than or equal to 10 adults because you can't have more than that. And this last one is saying if it's $8 per adult plus $3 per kid, if you add that up, you don't want to spend more than 80. That means 80 will be the most you want to spend. You want to spend below or equal to $80. So these are the three inequalities you could make from this scenario. And so for each of these, you're just reading carefully and making inequalities the best that you can. Next, write the factors for each graph. Well, the factors are what create the zeros. So if you see the zeros here, right here, boom, boom, and boom. So this particular zero, if you look carefully, you got to be careful on tests. You have to be careful. They don't always tell you exactly what the zero is. Like the increments would be off. So you have to look carefully. So that's -3. That's -6. You can just see that's -4. So if -4 is a 0, x plus 4 creates a 0 of -4. So this is the factor. This would be x plus what gives you 0? It's just x. And this is a 2, so x plus what gives you 2? X plus -2 or x minus 2. So these would be the three factors for this particular graph. If you were to make the equation, it would just be these three multiplied by each other with an a value that would be important as well. So if you look at each one of these, again, you just look at the zeros, and then the opposite of the zeros would be your factors. So for this next one, we are trying to name each of these graphs. Well, how do I know this one's an exponential? Because it has a horizontal asymptote. This is actually decay. So when you have a horizontal asymptote, you know it's going to be an exponential in this form. Now, how do I know this is a square root? It kind of looks like an exponential, but what happens here is there's no asymptote, and you see how it terminates there. When it terminates there, this is a square root graph that has a negative a value. Okay, this one, what is this? Well, you can see a vertical asymptote. So when you see a vertical asymptote like this, it is a logarithmic function because it's an exponential on its side because exponentials and log are inverses of each other. So back to this, what is this, an exponential? Because it has a horizontal asymptote down here. This is actually a growth. This one, do you see how it has like a square root graph, but it has two sides? That is called a cube root function. Your HK is right there, has a negative a value. Anyways, this one is a square root because it starts here and go to the right. There's no asymptotes. Here you can see a vertical asymptote, so this is a logarithmic with a negative a value. This one has a positive a value. This is a negative a value. Kind of important to think about when you're looking at your graphs. And this right here back to, looks like two square roots in each direction. That is a cube root function. Your HK is somewhere in here. And so for this section down here, you could use log to solve it, but it's a little bit easier. What you do is you try to find what base do they both share. Well, they both share a base 5. So this is really 5 squared. And then you both base 5, so you're basically saying x is greater than or equal to 2. That's where I got this. All right, this, okay, but they both are base 4 shared, so you put 2x, because, or I get 2x 4, because 16 is 4 squared. All right, and then that squared multiplies by the x, giving you a 2x. And then you set 2x is less than 1 right here, and you solve. Here, you have to look at the bases. This is 2 to the third. And this is just so to the x. So you say x is less than or equal to 3, and you're done. And then here you go, okay, 6. So this is 6 to the third, so this is 6 to the 3x. And then you say 3x is greater than 1, and then you solve it. Just be aware all the time with inequalities, you need to get the x on the left side. Now, if you struggle with inequalities, which direction they're going and stuff, and that's a worry for you, what you can always do is, you can act like this is, for instance, is an equal sign. And then you can plug numbers in on both sides to see which side is true. Again, you can act like this is an equal sign, get x equals 1/2, and then you can plug numbers on both sides to the original to see which is true. So if I want to find the quotient for this division problem, I could use full long division. But synthetic works because when I'm dividing by a nice, easy factor. So what you do when you want to divide by a nice clean factor is you find it 0. What makes it 0? -5, and you're using synthetic. So you take the coefficients of each term, make sure it's in standard form, make sure you put any zeros for any missing terms, and you simply put the coefficients of 1, -8, and 1. And then you bring down the 1. -5 times 1 is -5, add down. -5 times -13 is 65, add down. That's your remainder. So your remainder over your divisor, and then these terms are the terms in the polynomial for the result. So -13, this number ends up being the units digit. This is the x digit, so it's 1x. So you just start -13x. This is a remainder over the divisor. So here, let's look a little bit harder, a different one, a little bit longer one. So 4, this is a 1, -5, -3, 2. Bring down the 1, multiply the 2, put it there, add down. Multiply the 2, put it there, add down. Multiply the 2, put it here, add down. Again, this is a remainder over the divisor. You can put a plus -18 or a -18. This is your units digit. This is your x digit. And this becomes your x squared digit. So if you just look at all these, it's the same process over and over again. So for this one, I want to find what would be the equation of this graph. Well, first of all, looking at this graph, what kind of graph is this? Well, it's a logarithm because it looks like there's a vertical asymptote at -5. So if there is a vertical asymptote at -5, what that means, if you look at this carefully, is your inside is going to be x plus 5 because a -5 would cause an error. Okay, so the first thing you do is look for a log, again, because this is a vertical asymptote, that's an x plus 5 in here. So you look through all these and get rid of anyone that doesn't have an x plus 5. You know it's not going to be this one because it's not a log. So we crossed out a whole bunch. And then also, from that, hopefully that's really all you need to look at, because if we look at it, actually, let's look. It can't be this one because it's x minus 5. Okay, that one is the answer right here. Okay, x plus 5, but why do we cross those out? Why do I cross out these two? Well, see the -2? All right, the -2, it is a positive directional, so it has to be a positive. This would be a negative, so that doesn't make any sense. This one would actually work, but why is it this? Why is it not this one? Why is it this one? Well, the only difference between these two is a 3 in front. So how do we figure that kind of thing out? And what I would do is I would technically plug in a value. Now, don't plug in this one because this one's a little too close, and it's the same for both. If you try plugging -4 in, it will be the same for both functions. So again, if you plugged in -4, they'd be the same for these two, and you might not understand why. But if I plug in -1 to this one and to this one, you will find out the output is correct for this one. So sometimes you actually have to plug in values to verify which one it is. And then next is, how do you find these values? How do you find this? Well, f of -4 is just 1, because that's the output. F of -1 is just 4. And then if you subtract the 2, that's how you find these kind of results. Now, these two, you can hopefully tell, are square root graphs. Okay, this has a negative a value. This has a positive a value because it goes up. This is dropping. All right, and I hope with square roots you can see the a value as well. When I go over 1, I go down a half. When I go over 1, I go up a 1. Do you see how this is a -1/2 in front? This one has an over 1, up 1, so it's a +1 in front. And then next you look at HK. Okay, HK you have to look at is, well, my HK is -3, +1. So -3, +1 makes sense for both of these. So those are the key factors you need to be aware of. And you have to also understand a half power is a square root. And then next is you just have to look at your graph for these values and multiply them. You have to look at the graph for these two values and add them. So just be aware of those kind of things. Next, let's solve this equation. And now, when you have an exponent, most likely your answer is a log. So how do we get to this answer? Well, we have to get the exponent by itself, so we divide both sides by 8, and then you just simply change this to a log. I put the word log in front, and I switch the x and the 4. Done. And that's the same process for all of them. Divide by 5, put the log in front, switch the x and the 9. That's my answer. These log answers don't really they're decimals. They're irrational. You wouldn't really be able to calculate them without a calculator. Lastly, I just want to make sure you know how to find differences and sums and products and quotients of functions. So if we find the difference of two functions, first you have to find the functions from the list, and then you have to subtract the two. Just remember, you have to distribute that negative. So that negative becomes a negative 3x squared. That negative, that's a negative x, and that makes us a positive 7. And then we just combine like terms. So you combine the x squareds, you combine the x's, which have nothing to combine with, and you combine the numbers. So here, same idea as before. Make sure you distribute the negative, get a negative x, and that becomes a positive 3. Here you leave the 3x plus 5, and then you have to distribute the negative here. So when you distribute the negative, you will get a negative x squared and positive 5, and then you get to combine like terms. Last product, you have to multiply the two. So you first find f and g, and when we multiply the two, we just make a box, or you can use like a foiling method. And once you do the box, make sure you then combine like boxes, because these two boxes are the same. Otherwise, you go from highest power down. And then a quotient means divide. So if I'm going to divide G and H, so we put H out here, G here, and I use synthetic because it's easier. I found the 0 here is 3, put the coefficient of each one, bring down the 3 times 3 is 9, add down, 3 times 3, 10 is 30, add down, this becomes the remainder, and then this is your units term, your x term, and bam, I got a quotient. Remember, quotient is a division, product is a multiply, and difference is subtract.